Okay, so in this question, we're given 18 grams of aluminum nitrate, and we want to find all of these various things based on that 18 grams. So in part A, what they're asking us to find is grams of nitrogen in this 18-gram sample. So it's like if I had a pile of aluminum nitrate that weighed 18 grams, had a mass of 18 grams. I want to know how much of that 18 grams is because of the nitrogen that is part of this compound. So part of that mass is because of the aluminum, part is because of the nitrogen, part is because of the oxygen. So when we're going from grams of the whole to grams of a part, Ms. Prater showed you two ways of doing this. Both of them involve having to get the molecular weight though. So for aluminum nitrate, aluminum is 27. Then we have 3 nitrogens that each have molecular weight of 14 and 9 oxygens that each have a molecular weight of 16. So the molecular weight of aluminum nitrate is 213. Now, of that 213, it was this 3 times 14 that was because of the nitrogen. So 14 times 3 is 42. 42 of the 213 is nitrogen's contribution. If you wanted to set this up as a proportion like you've seen, remember that what you have here is nitrogen's molecular weight, and what you have here is aluminum nitrate's molecular weight. So on the other side of my proportion, I'm still going to have nitrogen and aluminum nitrate. But instead of being their molecular weights, I'm going to have their grams, grams of nitrogen and grams of aluminum nitrate. One of those is going to be missing. One of those is going to be my X that's unknown, and the other one I'll have been given in the question. So going back to the question, we had 18 grams of aluminum nitrate. That's why the 18 goes there. It's the grams of aluminum nitrate. And an X on top will let me solve for nitrogen. Cross multiplying this is what I think will work best for most of you. So 213 times X from here equals 42 times 18. And then we'll divide by 213. 42 times 18 divided by 213, we get 3.55. Now, if you wanted to not do the proportion and just use the percentage, what that would look like is you'd still do what we did here with the left-hand side, where you're still looking at the molecular weight of all of the nitrogens over the total molecular weight. What we're essentially finding here is the percent that is nitrogen. We're just not multiplying it by 100. 42 divided by 213. So this is 0.197. That would be 19.7% nitrogen. I could then take that percentage of 18. Again, mathematically, this is the same thing, just a different approach. And I still get 3.55 grams. Whichever of those two ways works for you is fine. They're literally mathematically the same, so just go with what you prefer. Then it wants moles of aluminum nitrate. So if I want moles of aluminum nitrate, I better use the grams of aluminum nitrate. So I am not using my answer for A here, because my answer for A is grams of just, I should have labeled it, grams of just nitrogen. I want the grams of aluminum nitrate, so I will use the moles of I want the moles of aluminum nitrate, so I'll use the grams of aluminum nitrate and the molecular weight of aluminum nitrate, which we found earlier was 213. So for those grams, what I'm going to be able to plug in here is the 18. 18 divide by 213. I will get my moles of aluminum nitrate to be 0.085. Now for C, I have my moles of aluminum nitrate. That's my moles of my whole, and they're asking me for a moles of a part of that. So remember, I just multiply by the subscript. So there are how many nitrogens in one molecule of aluminum nitrate? because that 3 outside of the parentheses distributes, there are 3 nitrogens here. So I'm going to multiply my answer from part B by 3. And we get 0.02, we get 0.254. That's it.